In the fast-paced world of DevOps, we prioritize speed. But sometimes, speed brings hidden dangers right into our production environments. Imagine pulling a container image that looks perfectly normal. It runs, it works, but deep inside, it carries a silent payload. We saw this recently with a compromised public registry. Developers pulled an image thinking it was the official build. It wasn't. That single untrusted source became a backdoor. Attackers didn't break in. They were invited in through a standard Docker pull command. This brings us to our first critical defense, image provenance. Fundamentally, do you know who built your code? Provenance isn't just about the source URL. It's about the entire supply chain. The commit, the builder, the timestamp. Secure organizations use cryptographic signing. If an image isn't signed by a trusted key, it should never start. Your orchestration platform needs to verify these signatures automatically. No signature? No deployment. Simple as that. But even a signed image can have vulnerabilities. That's where our second layer comes in, vulnerability scanning. Modern scanners look inside the container layers. They check the OS, the libraries, and the dependencies for known CVs. This shouldn't be a one-time check. New vulnerabilities are discovered daily. What's safe today might be critical tomorrow. Set policies to block deployment if critical vulnerabilities are found. Don't let a known exploit enter production. Automated gates in your CI/CD pipeline ensure that developers get feedback immediately, fixing issues before the merge. Now, let's talk about control. How do we stop someone from pulling Ubuntu latest from a random Docker Hub repo? Allow lists. Think of an allow list as a walled garden. You explicitly define which registries are safe. Everything else is denied by default. In Kubernetes, you can use admission controllers to enforce this. If the image source isn't on the list, the pod is rejected. Ideally, you should mirror public images to your internal private registry after they pass your security scans. This creates a sanitized supply chain. Internet to scanner. Scanner to private registry to production. Technology is great, but we also need to address the human factor. Shadow IT and convenient workarounds. Educate your teams. Explain why these blocks exist. It's not to slow them down, but to keep the platform alive. Keep an eye on your audit logs. Frequent denied pulls might indicate a broken workflow or a need for a new approved tool. To wrap up, remember the 3 pillars. 1. Provenance. Know the source. Verify the signature. 2. Scanning. Automate vulnerability checks and block critical CVEs before they deploy. And 3. Allow lists. Restrict where images can be pulled from. Trust only what you control. By implementing these controls, you turn your container registry from a vulnerability into a stronghold. Don't let an untrusted source compromise your mission. Stay vigilant and stay secure. Thanks for watching.